Like elimination, my goal with substitution is to get so that there's only one variable. So here, for example, this is not an equation I can solve. X plus y equals negative 32. I can't solve that equation. There's a lot of possibilities, right? This could be negative 16 and negative 16. It could be negative 32 and 0. It could be 0 and negative 32. So this is not an equation I can solve. And so my goal is to get an equation with one variable, which I can solve. Elimination was one strategy, and substitution is the strategy we're going to focus on today. So let's think about what substitution means, right? What does a substitute do at a school? Well, if a teacher is absent, right, then a substitute goes in their place. And that substitute is in all their classes, and if the teacher is supposed to cover a study hall or something, they do that, right? So whatever the teacher does, the substitute does. So this substitution is the same. It's the same meaning. And so let's take a look. Here I have an equation where I have y equals 3x and x plus y equals negative 32. These are my two equations. So I'm going to use color to help illustrate my point here. There's a y right here by itself, right? So there's a y. What does that y equal? It equals 3x. So these two items in the red boxes, they're the same, meaning I can substitute one for the other, right? Like let's say y is 6, then 3x must also equal 6. That's what the equal sign means. So what's cool about things being equal is I can change them in and out. So there's actually another y right here, and I can take this 3x because it's equal to this y, and I can change it out for that y. Now, why would I want to do that? Well, let's see what the result is. I'm going to write x plus, and instead of writing x plus y, I'm going to change out that y and put the 3x there instead. Now, what's my result? Well, my result is an equation I can solve. This is an equation that only has one variable instead of two. So now I can combine my terms. This is a 1x plus 3x. That's 4x. And divide by 4. Negative 32 divided by 4 is negative 8. That's my x value, and I need to plug back in to find my y value. Now, you can plug it into either equation as always, but I would argue this one, where it already has y equals, is way easier, right? Because that's already solved for y. So you just do y equals, and you plug in the x. 3 times negative 8 is negative 24. And there are my two values. X is negative 8, y is negative 24. And I'm done. Next example. Over here, I notice, I don't have a y by itself this time. But I do have an x by itself. That x is by itself. Well, what's equal to that x? This whole expression is equal to that x. So I can take this whole expression and I can substitute it in for any x I see. In the other equation, I notice an x right here. So I'm going to take this whole expression and I'm going to substitute it in for that x. Here's what it looks like. 2 times 2y plus 2 minus 3y equals 9. And this is exactly what I want. Notice there's only y's here, so I can solve this. Okay? Now I'm going to need to take the time to distribute first. 2 times 2 is 4. 2 times 2 is 4. Now in this case, I happen to have all positives, but be careful if you have negatives, right? You need to go slow and make sure you take care of those negatives. Let's see. Like terms, 4y minus 3y, that's 1y or just y. And y equals 5. Okay, still need an x value. I'm going to plug into this one where x is already by itself. So y is 5. 2 times 5 is 10. And 10 plus 2 is 12. So my x value is 12. My y value is 5. And I'm done. Your turn to try.